All right, so the lab that we're going to take a look at today is called Gravimetric Analysis. And the main question that this wants to answer is how much blank is in my blank, right? So in the case for our lab, what we're asking for is how much sulfate ion, so SO4 2 minus, is in my unknown. That's what we want to figure out through this lab. And so what we start off with is a solid unknown that contains some sulfate and then also contains some other stuff in there, right? So the first thing we're going to do is just dissolve it in some water. And so now everything's floating around in the water dissolved as ions. And then after that, we're going to add some barium chloride. And so the barium is going to interact with the sulfate to form barium sulfate. And so barium sulfate is insoluble, and so you'll get a solid precipitating out at the bottom. Right, so that'll be a solid. And then the rest of your stuff, it will stay in solution, right? Your whatever was in your unknown solid, as well as your chlorides, right? They'll also stay in solution. And then after that, all we have to do is filter and weigh the solid barium sulfate. And then using stoichiometry, we can go from the grams of barium sulfate that we had at the end back to the grams of sulfate in the unknown. And so that's the basic premise of the experiment. You'll see there's some additional steps that we take in real life, such as heating this to make nice large crystals, as well as testing to make sure that all the chloride is in solution and that none of it is actually inside or on our solid. But you'll see all of that throughout the video, and of course read through your lab manual. All right, so our first step is to weigh out between 0.6 and 0.65 grams of our unknown. So we've got unknown A right here, we've got a scale right there, and we're going to weigh it out in this weigh boat. So we'll put the weigh boat onto here, tare it, right, reading 0 again, and now we'll weigh out some of our unknown A. So we're going to do this using correct weighing technique. So we'll open up both sides, open up our unknown A, and then in one hand have unknown A, in the other hand have our scoopula, and then we're going to scoop over top of our weigh boat. That way, in case anything falls out, it'll fall right onto our weighing dish. Close up both sides and then read our weight. So we got 0.603 to 0.604 grams. Next thing up, we'll take our clean 600 milliliter beaker, and we'll go ahead and just pour this solid right into this beaker. Cool, and now we're ready for the next step. All right, so we've got our unknown in this beaker right here. Next thing we're gonna do is add 150 mils of water, which I have in these two graduated cylinders. It's just about, so it doesn't have to be exact. So there's 100. And then there's another 50. Give this a good little stir. And then we want to add 2 milliliters of our 6 molar hydrochloric acid. So we've got that right here in this little beaker. Transfer over some into my graduated cylinder and then add it to my solution. There's 2 mils there. Toss this into the solution, and then just give it a good stir. And now we're ready for the next step. All right, as you can see, I've got my dissolved unknown in one beaker, and then I have another beaker labeled for my barium chloride. So next thing out, we're going to measure out 50 mLs of our 5% barium chloride, which I've already done using this graduated cylinder. Just go ahead, pour that straight into here. And then we're going to want to heat the two to near boiling. So we'll put both of them on a hot plate next to each other. Turn up our heat, and then wait for this to come to near boiling. All right, so at this point our solutions are near boiling. You can tell there's a lot of condensation going on, and I actually stuck a thermometer in there, and it's reading about 90 degrees Celsius. Nah, it dropped then. It was at 90. Anyways, next step up, we're gonna slowly add our barium chloride into our unknown. And so you want to do this slowly, that way you get nice big crystals. If you get tiny crystals, later on they're going to go through the filter and it's just going to be a bigger pain in the end. So turn this around. I'll slowly pour some solution and then do a little bit of stirring. So make sure you have a good grasp on the flask using your hot glove, and then simply pour, and we should see the formation of a precipitate. And so you can see our solution getting white. That's that precipitate forming. And again, you just kind of want to do this very slowly. If I had a lab partner, maybe one of us could pour, one of us could stir. Cool. Got that in there. Move this over into the center. And now I'll just stir for several minutes. All right, so I've been stirring for about 3 minutes. I'm going to take it off the hot plate, put it down onto the lab bench, and then just let it settle for a couple of minutes. And what we want to wait for is till all the precipitate goes down into the bottom and we have a nice clear layer on the top. All right, so you can see I've let my unknown settle. You can see on the bottom is all the precipitate, and we've got a pretty clear supernatant up top. Next thing I'm going to do is I'm going to add some extra drops of barium chloride, right? Some more barium chloride in here. And what we're looking for here is any additional precipitation. If we see more precipitate form, then that means our precipitation wasn't complete and we need to add more barium chloride. If we don't see any precipitation, that means that we got all the sulfate out of there, and so then we can just go on to the next step. So let me rotate like this, and then I'll add some drops of barium chloride. And it'll be pretty obvious if you see precipitate. It'll be a white solid forming. So I got a little pipette, you can see it there. Add a couple drops. And you can see there's no precipitate. You can see some movement of the liquid, but there's no precipitate. That means that we got all the sulfate out of solution and we're good to go to the next step. Our next step is to take our solution and heat it back up for about half an hour. So we have our hot plate back here. Take our unknown, put it back on the hot plate, cover it with a watch glass, and then we're going to wait for it to reach 75 to 90 degrees Celsius, checking every now and then using a thermometer. Once it reaches 75 to 90 degrees Celsius, then we want to wait an additional 30 minutes to digest the precipitate. So your 30 minutes doesn't start until you hit 75 degrees Celsius. Again, here you want to be patient, because if you're not patient, it's going to screw up the experiment later on, and then you'll be back to square one. So a little bit of patience goes a long way. All right, so while our precipitate is digesting away, we can set up our filtration apparatus. You can see I have 2 ring stands here next to the vac line with some clamps on there. So I'm going to take 2 Erlenmeyers. One does not have a sidearm. One does have a sidearm. And so I'm going to put the sidearm one on the right here, clamp it into place. The one without the sidearm, place it in the middle, clamp it into place. Next up, I'm going to put some tubing in the center one, right? So this one's going to have 2 tubes going into it. Put that into place. One of them is going to go into the vacuum. And then the other one will go into the flask with the sidearm. And then I'll put our crucible holder into the one with the sidearm. And then our crucible filter will go up top here once we've weighed it out. And so the purpose of this is to just get a vacuum filtration going. So when we turn on the vacuum, it'll suck up some air. And we'll be doing everything on this right side here. This middle one is a trap. In case any liquid comes up through this tube, it'll get caught in this trap and not go to the vacuum where it could damage some expensive equipment. All right, so next up we've got to weigh our crucible here. So I've got my scale here. I'm just gonna put a piece of weigh paper on there just so my crucible isn't touching all the gunk on the scale. Tare it. And then weigh out my dry crucible. Cool. And now that we know the weight of this crucible, we can subtract this from our final weight and then get the mass of our barium sulfate. All right, so we can see our precipitate is still digesting away. Still got about 20 minutes. The thermometer is reading about 87 degrees Celsius. So I'm also going to add here about 200 mils of distilled water that we can use for washing purposes. So heat that up with our unknown. All right, so we've let our precipitate digest for over half an hour, and now we're going to start this filtration process. We need to filter this solution hot, so we're going to do this very carefully. First thing we're going to do is turn on our vacuum. So you should be able to hear kind of a bit of a sucking noise from the vacuum. It is indeed creating a suction. Next up, using our hot glove or some clamps, we're going to transfer our unknown. First off, we're just going to transfer the supernatant, so just the liquid part, into here. So you want to make sure that you have a very firm grasp on this. So that it doesn't slip out of your hand. And then slowly pour some into here. All right, now that we've gotten rid of most of the supernatant, we have to get the precipitate to filter through as well. So what you want to do is kind of just give it a little stir and then pour. Just a little bit of a stir and then pour. And then you can use your rubber policeman to help get out some more of the precipitate that's left over. You can also add a little bit of extra hot water. Give it a good stir. And then pour. Add a little bit more hot water. Give it a good stir. And then pour. Cool. And then you can see our beaker has no precipitate left in it. we've transferred it all throughout. And you can see our solution down here on the bottom is nice and clear because we did the experiment correctly. So we got large crystals and none of them went through the vacuum. Next up, we're going to want to wash our precipitate with some hot water. So maybe there's some chloride ions or something adhering to our crystals. We want to get rid of them. And so we're just going to pour about 10 ml portions through our crucible to wash our precipitate. It doesn't have to be exact, so I'm just going to eyeball it. So I got my hot water here. There's about 10 mLs. There's one portion. Second portion. And then our third portion. Put this back on the hot plate. Let it suction through a little bit, and now we want to do one more wash, but we want to capture this wash in a test tube. So I'll show you how to do that next. First thing we want to do is shut off our vacuum. And then we want to disconnect our vacuum right at this apparatus. Not up here, because that'll ruin the suction and it might push your stuff out of here and mess it all up. So you want to disconnect right here. Disconnect it. We're going to take our crucible off of here and just put it to the side for a moment. Carefully, of course. Take this out of here and dump this liquid into the waste container. You can see it is nice and clear. None of our stuff went through. All right, toss that all into the waste. Put this guy back onto here. And then what we're going to do is we're going to collect our portion inside of this test tube. So first thing we're going to do is lower the test tube in the sidearm. And so the trick here is to really find a good test tube of appropriate height. It can sometimes be a little tricky. So get that in there. And we're going to use the bottom here just to kind of move our test tube so that all the liquid will be lowered into the test tube. Clamp it on nice and tight. And then prepare to collect our final wash. I'll zoom in a little bit for this final wash. All right, so we're almost ready for our final wash. Reconnect the vacuum. You can see we've got our test tube in here. It's a little bit hard to see because all the condensation, but the test tube is in there. So all the water will flow straight into there. Turn on our vacuum. And then we're gonna wanna pour about 10 mLs. You just wanna make sure that you're not overfilling your test tube. So just this fourth wash, collect this one here. And that should be plenty. My test tube is about halfway full. That's pretty much all we want there. Turn off your vacuum. Disconnect at this joint right here. Remove your crucible. And carefully set it aside for the moment. And then we need to get this test tube out of here, which is a bit of a pain to get out. Let me get some clamps here instead. All right, so we've got our final wash right here. I was able to get it out of the Erlenmeyer using some forceps. It's kind of a pain in the butt part of the lab. If you're having trouble, ask your instructor. Don't try to do anything too crazy. Next up, we're going to add some silver nitrate into here, and this is to test if there are any chloride ions, right? This is our final wash, and so if our final wash still had chloride in it, that means that there's still chloride on our crystals that we want to get rid of to get an accurate measurement. So when we add the silver here, if chloride is present, we'll see a precipitation of silver chloride, and then we'll have to do additional washings. If we don't see a precipitate, that means that we did a good job washing and that we washed all the chloride away, and then we're done with this procedure, right? Because there's no chloride there. So Add 2 to 3 drops of my silver nitrate here. Right, added way more than 2 to 3 drops. That's fine. You can see that there's no precipitate being formed, right? There's no precipitate there. The little kind of murkiness is actually just from the test tube wasn't quite, the outside of it is a little, it just has some watermarks on it, but there's no precipitate there. And so that means we did a good job washing. This is really one of those labs that if you don't pay attention, if you don't do the steps correctly, you're gonna skip some steps, you're gonna skip some time, and then at the end, you're gonna have to redo stuff again and again and again. So you really wanna have patience and do this correctly, right? So that's done. We can take our crucible off of the rubber suction, place this inside of a beaker, and then we'll place this in the oven for about half an hour. Let's go ahead and just do that. Here's our oven, and then we're just going to let this dry to get rid of any excess water. That way we can get an accurate measurement. So we'll put that into there and let it dry for about half an hour. I don't have my name on it because I'm the only one in here, but of course you want to label yours to not confuse it with your classmates'. All right, so at this point we removed our crucible from the oven. Make sure when you're grabbing it out of the oven that you don't harm yourself. Hot glass and cold glass look the same. I put a piece of weigh paper on there, teared it down, so let's see how much this weighs. And then using this information, we can get the mass of our product.